I would like to sketch the graph of these parametric equations. X equals to 1 over root t plus 1, y equals to t over t plus 1, and then I would like t to be greater than negative 1. That makes sense because when t is equals to negative 1, you have a 0 in the denominator. So when you plug in t equals to negative 1, x and y, they are undefined. And then for the negative 0.5, I choose one negative value. You can try negative 0.25, negative 0.75. That's okay. You can definitely try more points. This one is 1 over negative 0.5 plus 1 would 0.5. And then this is negative 0.5 divided by 0.5. And then approximate that, you get a 1.4 comma negative 1. When x is equals to 0, I have 1 over root 1, and then this is 0 over 1. And then this is a 1 comma 0. When x is equals to 1, I have 1 over root 2. This is a 1 over root 3. This is a 1 over root 4. We take care of the big T at the end. When t is equals to 1, I have a 1 over 2, 2 over 3, and then a 3 over 4. This is a 0.7, comma 0.5. This is a 0.6, comma 0.7. This is a 0.5, comma 0.75. When t is very large, this one you have 1 divided by infinity plus 1, which is an infinity. That is nearly 0. And then the other one, you have a t over t plus 1. This is like a limit that you study in differential calculus when you study limit. Limit at infinity. As t approaches to infinity, since the highest power in the denominator is 1. Look at the denominator, first degree, right? And then I would divide each term by t raised to the first power. That gives you a 1 over 1 plus 1 over t. And then when you plug in a very large t, this is nearly 0. This is a 0 over 0. 1 over 1 plus 0, which is something close to 0, comma 1. Okay? Let's plot them. We started at undefined, and then we have negative 1.4, 1 all the way back to a 0. So the graph is supposed to be from right to left. Let's do it. Right to left, I will sketch the xy plane first. So this will be like that. X. And then a y, how about we do a 0.5? And then we do a 1. This is a negative 0.5, and then a negative 1. And then we have, I will say that would be enough. The first one is negative 1.4 comma negative 1. Okay, I also need something on the x-axis. I have 0, I have a 0.5, 1, 1.5, and then 2. Okay, 1.4 comma negative 1, right? You read your table. Negative 1.4 comma negative 1. That is right here. This is a negative 1.4 comma 1. And then what else do we have? And then the next point is 1 comma 0. 1 comma 0. And then we have a 0.7, 0.5. So this is a 0.7, 0.7.5. And then 0.6, 0.7. 0.6.7, and then 0.5, 0.75. Let's just put it right here, 0.5, 0.075, and then we are getting close to, this is exclusive, so this point is exclusive because x is not equals to, is not exactly 0. Okay, so I should say x is not exactly equals to 0. X is not exactly equal to 0. So we have a curve going from right to left, and then this is the orientation. X is not exactly 0. So that point must be exclusive. And then what else can we do? I can go from parametric to rectangular, right? Okay, let's do it. From parametric to rectangular. So next step is I would like to go from parametric to rectangular. How about I take this equation first? 1 over the square root of t plus 1. And then I can square both sides. That gives me x squared equals to 1 divided by t plus 1. And then I can do t plus 1 equals to 1 over x squared. In case you are stuck in this step, so how about 10 divided by 2 is equals to 5? 2 is equals to 10 divided by 5. How's that? You can follow that, right? The 10 divided by 2. And then I will subtract 1 on both sides. So I will finally isolate t on one side. 1 over x squared minus 1. I don't think it is necessary to do a common denominator at this point. The other equation is y equals to t over t plus 1. And then t must be greater than negative 1. All right, I will just plug in t. From where to where? From here to here. The t and t. Don't cancel them at this time. And then I have y equals to the top 1 over x squared minus 1, the bottom 1 over x squared minus 1, and then you have a plus 1. So that is a 1 over, I can get a common denominator right now. This is x squared, 1 minus x squared, and then divided by 1 over x squared. The x squared is in the denominator, so they got cancelled, and then this is 1 minus x squared. So I have y equals to 1 minus x squared, and then this is my rectangular equation. And then to get the same graph, you must say x is greater than 1 to make the 0, 1 exclusive. Okay, I am going to double check this really quick because I already put that on my notes. Hold on. Actually, it is not right. It is not right. I'm sorry. To get the same graph. No. I'm glad that I checked this now. X is greater than 0. X is greater than 0. I'm sorry, because that is how you make the same exclusive point. So this and that. This is X, and then this is a Y. So you should have an open circle right here. This is a 0, 1, and then it goes down like that, and then this is at 1, 0, 1 exclusive. We must make x greater than 0, not x greater than 1. Oh, that will be my mistake. Okay, so now everything is fixed. So we have we just went from parametric to rectangular, and then we have rectangular equation, x greater than 0, we have the same graph. So that is pretty much the end of this problem. I guess now this is a good time to take a screenshot right there. And then you can also take a screenshot right there if you are still writing the notes. All right, so I will just end this video right there. I will do more parametric equation. Maybe let's do some trigonometric function in the next video. All right, see you there.